In this video, we're going to examine another form of a line known as point-slope form. At the end of the lesson, you should be able to answer, how do I write and graph the equation of a line in point-slope form? Point-slope form is what you see on the screen, where the yellow M is the slope, and the ordered pair, x1, y1, represents a point that falls on the line. It looks complicated at first, but it's very easy. Here are 4 examples of equations in point-slope form. Let's see if we can identify the different elements. So the slope is the coefficient in front of the parentheses. So in the first one, it would be 1/2. Then it's -2. Here, it would be +1 because nothing's there, so it's understood to be 1, and the final one is 3. Now, the points. It is whatever is after the minus sign. So it would be 7 for x1 and 4 for y1. Now if you look at the equation and you see y minus 4, I just kind of remember that it's always the opposite of what I see. So I think opposite, opposite as I identify my point. So in the next one, opposite, I see x minus 9, so the opposite would be +9, -3. Now mathematically why it's -3 is if it's whatever is after the minus sign, this is equivalent to y minus -3, so -3 is the y1. Next one, opposite opposite would be -1, -10. Opposite of -5 would be +5, and then 0 because there is no y value listed. In example A, we're asked to actually graph the line given in point-slope form. So I see that my slope is +2, and the ordered pair that's given would be, think opposite, opposite, +1, +3. So I begin by graphing that value, 1, 3, and then I have a slope of 2. So I would go up 2, right 1, or down 2, left 1. So that gives me a few points, enough to connect and make my line. And I'm just going to add arrows to either end. Now, in number 2, let's identify our point and slope. So the slope is -1/2, and the point, again, opposite opposite, would be 4, -2. So I start by graphing 4, -2, and it has a slope of down 1, right 2 for -1/2, or up 1, left 2. Again, that is enough values to construct my nice straight line. So it looks like this. I kind of missed my points just a little bit. The arrows on either end indicate that it goes on forever. Example B asks me to write the equation of the line that's given in point-slope form. And on your note guide, you'll see that I made a very big point for you. However, if that's not given, you just choose any point on the line. So the equation could be expressed in multiple ways. So I set up my equation, putting my variables in, and then I'm going to figure out what values go in for my slope. So my slope looks like rise 1, run 3, rise 1, run 3. So my slope is 1/3. This ordered pair is the ordered pair -3, +2. So here's x1 and here's y1. So when I put it into the equation, enter it as the opposite. So this would be +3 and -2. There it is in point-slope form. Example C is hoping that you will see the similarities between point-slope form and slope-intercept form. So we are to start by graphing and then writing the equation of a line in point-slope form. So we're given that the slope is 1/2 and it goes through the point 2, -6. So I am plotting my first ordered pair at 2, -6, and it has a slope of 1/2, so it's going to go up 1, right 2, up 1, right 2, or down 1, left 2. I'm going to draw my straight line and add arrows to either end. Now one of the things that I can immediately see here is it's crossing the y-axis at a nice integer value,
I'm going to identify what that is just by counting. So that's negative 2, 3, 4, 5, 6, 7. That looks like B would have to be negative 7 if I'm thinking about slope-intercept form. So slope-intercept form would have the same slope. It would be y equals 1/2 x, but it would be minus 7. And let's look at how we can get that from both point-slope form or by looking at the graph. So in point-slope form, set it up. The slope is 1/2. Opposite for my point, so I put negative 2 and positive 6. There it is in point-slope form, and that's a completely acceptable answer if you're asked to give the equation of a line. But if you're asked to change this, like the directions do, to slope-intercept, I need to isolate y, so I'd start by distributing to get rid of my parentheses, which gives me y plus 6 equals 1/2 x minus 1. To get x alone, or to get y alone, subtract 6 from each side, and I get y equals 1/2 x minus 7, which I can see from what I graphed from the given information. In the last one, it's just like the previous one. We are to write the equation in both point-slope and slope-intercept form. So I'm going to start with point-slope form. It has a slope of negative 1. It goes through 3, 5, so think opposite would be negative 3, and then negative 5. I wrote positive, should be negative 5. So I'm going to now graph my given information. 3, 5 is right here, and it has a slope of negative 1. So it's going down 1, right 1, down 1, right 1, or up 1, left 1. And there I can construct my line, put arrows on either end. And again, here's another nice one to see where it crosses the, oops, let me just try that again. I can see where it crosses the y-axis, and that value looks like 1, 2, 3, 4, 5, 6, 7, 8. Looks like that is positive 8. So, from what I know about slope-intercept form, this would have to be y equals negative 1x or negative x plus 8. And let's see if I can get that algebraically by distributing and isolating y. So I distribute negative 1, which gives me y minus 5 equals negative 1x or negative x plus 3. Then I add 5 to both sides, and I do get y equals negative 1x plus 8. So I can see that these two forms of the line are equivalent to one another, and that the graph makes sense as well. So for most problems, you can decide what you like most. If I am given the point and a slope of a line and I'm told to find the equation, I normally start with point-slope form. Some kids always prefer slope-intercept, but really, either form is acceptable.